I'm Jon.
I'm Brooke. He's Jon.
I thought we were going to sing this.
I'm Brooke.
Didn't we say we were going to sing this? Shit, dude.
Good morning. So, we are talking about compressive strength.
Say what?
Compressive strength.
Say what?
Compressive strength.
ASTMC 39 to be exact.
Yes.
And do you mind grabbing us a sample? Please? Oh, wait, we have.
Sure. Yeah.
So here's a concrete cylinder. It's a small one. It's a baby.
Little guy.
It's cute. There's also bigger ones, 3x6s. So this is a 2-inch by 4-inch.
Mm-hmm.
There's 3-inch by 6-inch, 4x8, 6x12s. I believe there's even 3 foot by 6 foot, 2 foot by 4 foot, and even larger ones. I guess that would be.
Glad we don't use those.
I'd like to.
Really?
Pure reclamation. Yeah, they have a 3-story, 3 million pound. Really cool. Anyway, what we do with this is what, Brooke?
We take measurements, cross-sectional measurements, and then we either use a bonded cap like sulfur, gypsum, neat cement paste, or unbonded cap pads, and put the pads on each side if it's an unbonded cap, and then
Put some tequila.
put it in the compressive machine and apply a force load.
What kind of force? Starts with a uni.
Fied.
Nope. Ends with something that sounds like schmaxial.
Axial.
And then the last word rhymes with schmode.
Load.
Yeah! Uniaxial load. So a uniaxial compressive load, and we say uniaxial if these, this is our flexural beam that we use, but this is an up and down axis. So we put our sample here. That compressive loaders or that squeezing load is going through one axis. We're not putting like a bending load on it or a shearing load or a weird angled. It's a uniaxial direction, and we're squeezing the ever-living snot out of it until it fails.
Yes.
And then what?
Say what? We're squeezing it on both ends. That's it.
So once it fails,
Yes.
when we start seeing this cracking pattern where it can no longer hold, 85% of its sustained load?
Yeah.
I think it's 85%.
I think it is.
Hey, listen, if we miss these numbers by a few, don't hang us to dry. We're just trying to teach y'all. Yeah, always good concrete practices dictate that you always look at the ASTMs. We've got CCRL coming up, so don't take this word for scripture. Go to church for that.
And read the ASTM before you do the
That's
test.
what I meant!
That's all. Yeah,
I
that's
didn't-
church.
I didn't know how to. Really
Bible.
terrible analogy.
Yeah.
Terrible analogy. So we squeeze this until and the equipment has a telltale on us that tells us the maximum load at fracture.
Yes.
Then what do we do?
Yes. So we record that, the max load force per pound, and the way that we get the PSI is then we use the calculation of the, radius,
Well, first of all, what does PSI mean?
pounds per square inch.
Okay, so in our equation, we take
The pounds,
at failure, divided by
square inch,
to get.
PSI.
There you fucking go, Batman.
Say what?
Say what? And the reason why we like that equation, whether we do a uniaxial compressive load, we're squeezing it, or we do the opposite, we pull the sample, we're using the same equation, despite the fact that we're going from uniaxial compression to uniaxial tension. Isn't that cool?
That is very cool.
Now, Brooke, why do you think compressive strength is so important? I'm gonna go wash my hands.
Tells us the weight bearing load that a mix can handle. I mean, think of
And then
a bridge or something like that that's suspended. Obviously, you don't want to overload it and cause failure
Sure.
and death. Just saying.
Dude, that was pretty serious for a Friday.
No. Tuesday at noon.
So one of the things that it's not one of the things, ACI 318, which is our our reinforced concrete shtick that we go back to for design work, it uses compressive strength for almost everything. There is a conversion equation or factor to take compressive strength to flexural strength, tensile strength. There's even durability factors that deal with compressive strength. Like the DOTs. We did a talk on that. If you, for certain DOTs, if you were tasked to, use a 5,500 PSI concrete and your concrete at 28 days broke at 5,000 PSI, they charge you for, was it not early demolition, but the structure to fail early because you didn't meet a certain strength. So compressive strength, for every junior engineer, that's all you learn about. You learn about more things.
Typical. So you're saying like there's standards to use for that mixes need to meet to be acceptable for different
applications.
Yeah, okay.
Yeah, totally. But most of them focus on compressive strength, and now more of them are starting to. A few of them are going to flexural strength and then durability tests like surface resistivity, RCPT, alkali silica reactivity.
Say what?
Say what? All right, so that was the basics of compression strength. Ooh, I can't say it either. That is the basics of compressive strength.
C39.
F prime C. Let us know if you got any concrete questions.
Go concrete.
No,
I don't know all that.
Oh.
Ring the bell, like our page.
I feel like I just got in so much trouble. We can start that over again.
Okay, yeah. You say it though, because I don't know the whole spiel.
Sure. Okay, ready?
Yeah.
Okay, where was I? Oh, baby girl.
Thanks for watching.
No, that's not for you, baby girl. What am I in trouble for?
You threw it.
Well, at least I would have gotten coffee for Brooke. Hey, that's not for you. Thanks for watching.
Like our page.
No.
I don't know it. Ring the bell.
Watch Haley. She'll say what you have to say next. Okay, we'll try it that way.
Okay.
Thanks for watching.
Don't forget to like our channel.
No.
I don't know.
Okay, you start with thanks for
How about,
watching.
yeah, okay. Thanks for watching.
Don't forget to like and subscribe.
Ring that bell for notifications.
Go concrete!
Beat asphalt.